All right, good afternoon. Today we're going to be learning about rational exponents, and it appears that one of my students thought they were really funny and changed the title of my thing here to fractional instead of what it should say. How lame of them? Rational. We are doing rational exponents today, but I did underline the word rational because it is true that another way of saying rational is fractional, meaning that the exponent is now a fraction. So this is basically the conversion here. If you have the nth root of a, it's the same thing as a to the 1 over n powered. You might not believe me, but we can try something really simple. For example, you all know what the square root of 4 is. The square root of 4 equals 2. And what I'm going to suggest we do is that if I convert the square root of 4, which means it has an index of 2, and the exponent is 1, then as a fractional exponent, that's going to be 4 to the 1/2 power. And if you want to go to your calculator and type in 4 and then raise it to the 1/2 power, make sure that you put the 1/2 in parentheses or that you use a decimal, and you will in fact get 2. That's something that you can try at home and just double check for you. Also, we have over here, again, these peeps, they're trying to see if we're on our toes here. And it's a good thing that I am on my toes right now, because again, they put a negative in front of this, and they shouldn't have. This is what happens when you leave your board unattended. There's no negative there. The formula is a to the m over n powered equals the nth root of a to the m, which is the same thing as the nth root of a. Look at these people. What is wrong with them? I'm going to have to smack that study hall. And Mark was in here.
That was Jake Nelson.
So, Jake Nelson, they just ratted you out. Awesome. So anyway, this is also, what if your exponent doesn't have to the 1 power, for example? What if you had, I don't know, the square root of like 5 to the 3rd power, something like that. Well, in this case, the index is 2, and the exponent inside the little house is 3. So we can write that as a fractional exponent by putting 5. And the top number, you'll see the top of the fraction is the exponent from the inside, so 3. And the bottom of the fraction is the index, so 3/2. So the square root of 5 cubed will be the same thing as 5 to the 3/2 power. And again, you can put that in the calculator to make sure that it's the same value. The other thing that they changed, oh my goodness, Jake, I'm going to smack you, is 7.5. It's not 7.5, it's 7.4. OMG. So, moving on. We're going to try some examples, and hopefully we didn't screw around with these. It looks good. We're going to simplify each expression. I'm going to show you how to do that. Again, based on what we did earlier. So, 125 to the 1/3 power is the same thing as the cube root of 125, which we know is 5. We're looking for a number that multiplies by itself 3 times to get 125, and that number is 5. 5 times 5 is 25. 25 times 5 is 125. So there's that. 5 to the 1/2 power here, what you can do is you can rewrite these to square roots, because we can convert the fractional exponent into a radical, and that's 1/2 is going to be square root. So that means that we have square root of 5 times the square root of 5, which is the square root of 25. And again, the square root of 25 is 5. So awesome. And then over here, we're going to have the cube root of 10. So the 1/3 exponent becomes a cubed root. And the cubed root of 100. And that becomes the cubed root of 1,000, because you multiply 10 times 100. And the cubed root of 1,000 is in fact 10. So that is how we do that, and I'm going to give you a chance to try some on your own. And there they are. Now we're going to try to go both directions here. What we're going to do is let's write the exponential expressions in radical form. So this one's really simple. Like we did earlier, we had the top and the bottom. Remember, the bottom number is the index. So that's going to be a 5 for my index. And the top number is the exponent inside the radical. So there we go, 5th root of x to the 3rd power. For this one, we actually need a couple of things. Hopefully you remember that when you have a negative exponent, that you have to move it to the bottom. And I want to make sure that that wasn't something that we just kind of put there. So we're going to do this. When you move the variable to the bottom of the fraction, that negative exponent becomes a positive exponent. But the other problem is that we don't have a fraction for 2.5. You want to take 2.5 and write it as a fraction because that's how we're going to get the radical expression. So 2.5 can be written as 5 halves. So we're going to write 1 over y to the 5 halves power, like that. And again, because the 2 is on the bottom, that's the index, so it's going to be square root of y to the 5th. And it's under the 1, so there you go. 1 over the square root of y to the 5th. In this case, you don't want to get rid of the square root on the bottom. So there you go. Now you can try a couple here on your own. Remember to convert the 0.4 to a fraction. And you can do that on the calculator by hitting the fraction button. And now we're going to go the other direction. In this case, they want us to go from radical form to exponential form. So this index is a 2. Remember that if it's not explicitly written, you assume that it's a 2. So that would be a, the number inside the radical goes on top, the index goes on the bottom. So a to the 3 halves power. Done. In this case, we have b to the 1/5 power because this is b to the 1 power inside the radical. That number goes on top, index goes on the bottom. And then I have a square out there. And again, you will recall from before that the property of exponents says if you have a power raised to a power, you multiply them. So at the end of the day, this is b to the 2/5 power. Awesome. So now we are going to let you try those. Awesome. Okay. So here are the properties of exponents in case you have forgotten them. These are the properties that we did like in Algebra 1 back in the day. So I just want to remind you what they are. We have, if you have the same base and you're multiplying, then you add the exponents. If you are dividing the same base, you subtract the exponents. Here's the one we talked about earlier. If you have a power raised to a power, you multiply the exponents. If the exponent is negative, you reciprocate it, so it goes to the bottom. If you have a product where you have a times b to the m power, then the m gets distributed to both a and b. And the same thing happens here when you're dividing a by b. You have to distribute the power to both a and b. These properties we've done in the past, and they are still true for fractions. It just means that you have to add and subtract fractions instead of regular numbers. So here we go. They want us to simplify each number. Here's an example. So we're going to say negative 32 to the 3/5 power. So that's going to be negative 32 cubed. And then the 5th root is going to be out here. All right, because the 5 is on the bottom. So to do that, we're going to go ahead and you're going to get a decimal in this case if you use the calculator. So you want to make sure that you're not using the calculator for these kinds of things. Alrighty then, where am I at here? This is what I'm going to do. It's going to be convenient for us to write this problem with 5th root of negative 32 and then raise it to the 3rd power. And you can do this because if you look at the properties of exponents, there's a couple of ways that you can write this. You can either say negative 32 to the 1/5 power and then to the 3rd power. And the reason why you can do that is because 1/5 times the power raised to a power, 1/5 times 3 is 3/5. That's one option. Another option is for you to write negative 32 to the 3rd power and then put the 1/5 outside because again, it doesn't matter which order you multiply in. 3 times 1/5 is still 3/5 or 1/5 times 3 is still 3/5. Now the reason why I'm not going to use this option is because I don't know what negative 32 to the 3rd power is. But I do know what negative 32 to the 1/5 power is. And that's 2, negative 2. if I take negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8, and negative 8 times positive 2, I'm already getting confused, is 16, and 16 times negative 2 is negative 32. 5 times. So this is negative 2. So now I have negative 2 to the third power, which is just negative 8. So it's convenient for me to put the 1/5 on the inside because I know that the 5th root of negative 32 is negative 2, and then I just take that to the third power and I get negative 8. So that is how you do that little guy. And now we're going to do this other one over here, 4 to the negative 3.5 power. And we already said that if it's negative, you got to move it to the bottom and make it 4 to the positive 3.5 power. And we want to rewrite 3.5 into a fraction. I wonder if anyone in my pre-calc class knows what that would be. They don't care what I'm doing right now. It's 7/2. 7/2 is the same thing as 3.5. And again, we have options. We can take 4 to the 7th power and then put the 1/2 out here. Right, Joshua? Because 7 times 1/2 is 7/2. Or we can take 4 to the 1/2 power and then raise it to the 7. Either way, you get 7/2. Now, which do you think is going to be the most beneficial for us? The 4 to the 1/2. Why? Because 4 to the 1/2 is the same thing as the square root of 4. And I'm pretty sure that you all know what the square root of 4 is. The square root of 4 is 2. And then we can go 2 to the 7th power. Instead of trying to go 4 to the 7th power, which is a really big number, and then square root it. So what is 2 to the 7th power? I have no idea. But we're going to find out right now. 2 to the 7th power is apparently 128. So that would be my final answer. So again, with this example, we want you to be kind of cautious about which direction to rewrite these fractions, and hopefully you'll do it in a way that is convenient for you to get the right answer. Alrighty, so now you're going to try these. And then I have, I believe, one more example for you, and that's this little guy. They want us to write this expression in simplest form, which wouldn't include negative exponents. So we're going to, what's happening here is you've got two things inside the parentheses. So that's like the property where you had a times b to the m power. You have two different things being raised to a power. So we have to distribute that power to both. So that's going to be 16 to the negative 3/4 power. And then you have y to the negative 8 power. And then that has to be raised to the negative 3/4 power. Okay? So then we're going to simplify that further. I'm going to leave the negative 3/4 there for now. And then here we're going to multiply the exponents because the power raised to a power. So negative times negative is going to be positive. 8 times 3 is 24 divided by 4 is 6. So we're going to get y to the 6. So that's nice because now the y is no longer has a negative exponent. So then I can leave my y on top, and I have to move this guy to the bottom to make it positive. 16 to the 3/4 power. And now I need to figure out how I can simplify 16 to the 3/4 power. So I'm going to go 16 to the 1/4 and then 3 out here. If I do that, then 1/4 times 3 is 3/4, and this is the 4th root of 16, which I do believe is 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So the 4th root of 16 is 2. So I'm going to replace all of this with the 2, and it's to the 3rd power, which means in the end I get 8. So now my final answer is y to the 6th power over 8. There is my final answer. So now you will try one on your own, and once you have done that, you will have completed the lesson for today. And thanks for watching.